Okay, so we've now got a lot of great information here that we've been able to pull straight from the subgraph for Uniswap v3. Now we need to go and actually calculate surface rate prices. But before we can do that, the first thing we need to do is actually go and structure the pairs. Just like we did with Poloniex, we need to go through and make sure that we go and group all the tradable pairs that we've got here into triangular arbitrage or triangular arbitrage tradable groups. So the first thing I'm going to do here, actually, rather than calling this mid prices, is I'm going to call this pairs. And what I'm going to do here as well is I'm going to take this data pools and add this to the end of this function. So what that'll do is actually return the result, but also dive into the data and pools section so we actually just get the prices. So let me just show you very quickly. If I go and run that here with a print statement just for pairs, let me show you exactly what that looks like. So now it's basically got the same thing, right? It's done exactly the same thing, except now there's no data and pools at the start of these arrays here, or these lists. So here, for example, if I put in, I don't know, item 10, and we go and run that, you'll see here we've got item 10 that it's just pulled. So that's very useful to have. So the next thing we need to do now is actually go and structure, as we said, this list, the list of all the possible pairs, into triangular arbitrage tradable groups. So to do this, I'm actually going to start creating some functions, but not up here, because I don't want this file where we're controlling what we're running and when getting too cluttered with, all sorts of methods, etc. here. So what I'm going to do is right click here, go to new Python file, and again, make sure you're on Uniswap, right? Or make sure you're on the project folder, not on the VNV. So here you want to go new Python file, and we're going to call this, func triangular arbs, or arb, that's fine. And this is where we're going to put all of our functions that we need to compute here. So the first one we're going to put here is to structure the trading pairs. So structure trading group or pair groups. You can see there's no consistency between how I named it before when doing CFI, but it's fine. Just name it in a way that makes sense to you. So here, again, we're going to structure trading pairs. And what we want to do here is just pass in the pairs information. So right now, all I'm going to do here is close that and go print pairs, just to make sure that's all coming across okay. And then down here, what I want to do is import func triangular arb. And what we're going to do with that is we're going to now go and run. We're going to say, for example, the structured pairs is equal to func triangular arb dot structure trading pairs. And we need to pass into that this pairs. So that's now going to take this pairs object, pass it into here, and if all worked, and I'm just going to print out, one object here, if all worked, then that should work absolutely fine. Let's go and run that, and there it is. It works absolutely fine. So same as before. Now what we need to do is put in here triangular pairs list, which is equal to this, remove duplicates list, which is equal to that, and pairs list, which is equal to this. And if this isn't making sense to you right now, just go back and look at the equivalent video where we did this for Poloniex. You're not going to see anything new here. The only thing that you're going to be seeing that is different now in this time round is that there's just different references we need to make because the data is different. We're getting different data in the objects, but the approach and the principles are exactly the same. The reason I'm going through it again, rather than just copying and pasting it over, then making some adjustments, is because seeing this for a second time round in a different way, again, will really help to instill in you what's actually going on here in principle. So here, what we're going to do essentially is we're going to loop through each coin to find potential matches. What we need to do here is actually make pairs list equal to pairs. And I'm just going to make this the first, let's say 0 to 20 pairs. I don't want to do this for all 500. And we did this trick earlier as well, just to keep things nice and lean. So they're running fast just for testing. And then I can open this up to the whole, 500 coins or whatever we were able to retrieve. So here we're going to say for pair A in pairs list, which is now, the first 20 objects of pairs that we've passed in here. And what we need to do here is just say, get first pair A. And pair A is essentially going to be as follows. So we need a base, just like we had before, a base, a quote, etc. And that is going to be equal to pair A. And if we look down here, we've got a number of things we can pull here, right? So we've got token 0, for example. So token 0. And with token 0, we've got the symbol USDC. That's what I want to get. I want to get USDC, and I want to get here for the next one as well, for token 1, WETH. So here what I need is, for pair A, I need to get token 0. And here what I want is the symbol. And what I'm going to do here is just get rid of these double equals, because that's just incorrect. And we're going to print a base. Now when I go and run that, you see all of the A bases, and you can see here there's 20 of them. And the reason there's 20 is because we've limited this to 20. And we're going to duplicate this and call this a quote. So a quote is going to be token 1 symbol. So let's now pull a base and a quote and print that out. And hopefully this is now making sense to you what we're doing. We're just extracting that data out of the objects that we've passed into this method or function. So a pair, I'm actually going to explicitly call this out as a pair this time. And I'm going to say that that is a base plus, and I'd like to keep the same kind of convention as we had with Poloniex. I want this underscore here, and that's going to be a quote. And I'd like the contract addresses as well. So this will be a token 0 ID, and that's going to be equal to pair A. And again, this is going to be symbol, token 0. And then here, this will be ID. And this will give us the smart contract address so that we can reference this and, pull any information with this address that we need to for token 0. And essentially what I'm doing is calling, token 0, we're calling this as the first symbol, and then the quote is the second symbol, which is token 1. So the first symbol is token 0, the second symbol is token 1, but we're calling this a base and a quote. It's all still part of the same pair. Right, it's the same pool of information. So here we're going to pull that ID, and then here this is going to be token 1 ID. So that's going to be token 1 ID. Now just to check this is working, let's just go and run this again and print this for a token 1 ID and hit play. And here it is. And it would run even quicker if I just saved the JSON object as a text file and pulled it in, similar to what we did before. But because GraphQL is just so fast, there's no need for it. This is fine. And here's all the contract addresses that are pulling for token 1. So that seems to be working just fine. So a contract, because we need the contract, we need to know, what are the pool contracts we're working with, is equal to pair A ID, and then a token 0 decimals, because I want to capture the decimal information, is going to be equal to pair A, and that's going to be token 0. And then here, we don't want the symbol information this time, we want the decimals information. And I'm going to do the same here for token 1, token 0. So that makes sense, and that needs to be a 1 here as well. And then a token 0, we want the price as well. That's very important. Is going to be equal to pair A, and that is going to be pulling here token 0 price, and this is going to be the same for token 1. So that's going to be token 1 price. And that should be it. That should be all the information we could possibly want. So what I'm going to do here is just print some random information. I want the contract. And this is, again, just for sense checking, right? You could print everything. But this is just to make sure things run. And you'll see I just always do this. I'm always running things to make sure I haven't made mistakes. And even then, I'm still making mistakes. And there's the prices. There's the number of decimals. In fact, let's actually pull the A pair as well so we can see what all of these relate to. It's the contract, and I'm just going to right click up here and run it this way. Doesn't matter which way you do it. And there you go. So here's the pairs, here's the contract pool address, here's the number of decimals, for example. It really doesn't matter what you want to test, but it's all working very, very well.